Hello everyone, sections 9.4, 9.5, and 9.6. Altogether, the sine, cosine, and tangent ratios for solving right triangles. What is a trigonometric ratio? Well, we saw back in section 9.3 that there are only so many ratios that you can write out of all the different sides of a right triangle. We saw it becomes a little bit more complicated when you put in an altitude. But in general, there are only 6 possibilities for writing out ratios of all the different sides of a right triangle. We could do, and this is important, that when we are naming things in a right triangle, naming sides, this is always the hypotenuse. That's not going to change. That was true a long time ago. But when we were doing earlier in this section, in this chapter, we were doing leg, leg, hypotenuse. Sometimes we would say short leg, long leg, hypotenuse, but we didn't get much more detailed than that. Now, where you are becomes very important. If you're here at angle A, point A, then this leg here becomes adjacent to angle A. It's adjacent to where you are. But if you were over here at point B, angle B, then this same side, AC, is no longer adjacent to angle B, it's opposite angle B because of where you're standing, okay? And that's important for you to know. So, like I said, there are only so many different possible combinations. There are only 6 of them, right? We can do opposite angle A over hypotenuse. We can do opposite angle B over hypotenuse, opposite angle A over hypotenuse, adjacent to angle A over adjacent to angle B. So different things, right? But there's only 6 possibilities. 3 of them we give names to, sine, cosine, and tangent. And the other 3 we give names to that you'll learn when you take trig and precalculus, secant, cosecant, and cotangent. But for now, the only ones you care about, or we care about, are sine, cosine, and tangent. That's really all trigonometric ratios are. They're names of 3 of the 6 ratios in a right triangle. Okay, so what are they? Well, sine of angle A, so this is telling us where we are. Sine of angle A, we're here at angle A, is equal to opposite of angle A, or BC, over the hypotenuse, AB. Okay, cosine of angle A. Cosine of angle, so I'm still here at angle A. Cosine of angle A is now adjacent to angle A, which is AC, over the hypotenuse, which is still AB. Tangent of angle A. Tangent of angle A, again, we're still here at point A. Tangent of angle A is equal to the opposite of angle A over the adjacent to angle A. So opposite angle A is BC, and adjacent to angle A is AC. Okay, these are the 3 ratios that we get if you're standing at point A. If we're standing at point B, we get different ratios. Sine of angle B. It's still the same relationship. So sine of angle A was BC over AB. That was opposite angle A over the hypotenuse. Well, now we're at B, so we got to look at opposite angle B. That's now AC. Over the hypotenuse doesn't change. That's still AB. Cosine of angle B. Well, cosine of angle A was adjacent to angle A over the hypotenuse, but now we're at B. What's adjacent to B is BC over the hypotenuse, which is still AB. Tangent of angle B. Tangent of angle A was opposite angle A over adjacent to angle A. But now we're at B. What's opposite angle B is AC. And what's adjacent to angle B is BC. Okay, now you can memorize all these ratios, or you can remember this simple mnemonic device, which we pronounce SOHCAHTOA. It's not something that I've made up. It's been around for a very long time. Each letter stands for a word. S stands for sine. O stands for opposite. H stands for hypotenuse. C stands for cosine. A stands for adjacent. H stands for hypotenuse. T stands for tangent. O stands for opposite. And A, again, is adjacent. What does all that mean? Sine is equal to opposite over hypotenuse. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And a tangent is equal to opposite over adjacent. Okay, tangent is equal to opposite over adjacent. So these three ratios are true for all right triangles. It's a property of similar triangles. Okay, so here are the official definitions for tangent, sine, and cosine. And again, that just means that they're the different ratios. Okay. Example 1. Find each ratio. What is the sine of angle T? So we know that we're standing here at angle T. SOHCAHTOA tells us that sine is opposite over hypotenuse. What's opposite angle T? 7 over 25. Cosine of angle T. SOHCAHTOA. C-A-H. Adjacent over hypotenuse. 24 over 25. Tangent of angle T. TOA. T-O-A. Tangent is equal to opposite over adjacent. 7 over 24. Moving to a different location. Sine of angle G. Now we're here. Sine of angle G. Sine, SO, S-O-H. Sine is opposite over hypotenuse. Opposite is 24. Over the hypotenuse is 25. Cosine. So TOA. C-A-H. Cosine is equal to adjacent over hypotenuse. Adjacent is 7. Hypotenuse is 25. Tangent. TOA. T-O-A. We're here at angle G. Opposite over adjacent. Opposite is 24. Adjacent is 7. All right. Find any pattern and or connections. Sine of angle T is equal to the cosine of angle G. Sine angle T equals the cosine angle G. Right? Cosine of angle T is equal to the sine of angle G. Tangent of angle T is the reciprocal of tangent of angle G. Tangent of angle T equals the reciprocal, 1 over tangent of angle G. Okay. Let's take it one step further. What do we know about angles T and G? What do we know about angles T and G? Well, there are two angles in the right triangle. More specifically, they are the two acute angles in the right triangle. What does that mean? Well, if they're the two acute angles in a right triangle, what do we know about the two acute angles of any right triangle? We know that angle T and angle G are complementary. Okay, what does that mean? That means the sine of an angle is equal to the cosine of its complement. The cosine of an angle is equal to the sine of its complement. Tangent of an angle is equal to the reciprocal of the tangent of its complement. These are the ones that we really care about right here. Sine of an angle, and let's call that angle, gotta look ahead, we'll call it angle A, is equal to the cosine of its complement. What's the complement to angle A? 90 minus angle A. Which is also the same is true for cosine of angle A is equal to the sine of 90 minus angle A. Now, I want you to think about this. Sine is equal to the cosine of its complement. What are the first two letters in complementary angles? CO, co. Sine, cosine. Cosine, sine. Yes, there is a cofunction to tangent. It's called cotangent. And then you'll find when you take trig and pre-calculus, there's also a secant and a cosecant. And that's what this says here, sine and cosine of complementary angles. Okay. Example 2. In triangle ABC, tangent of angle A is equal to square root of 7 over 3, and the sine of angle A is equal to square root of 7 over 4. Here's angle A. Tangent, SOHCAHTOA, is opposite over adjacent. Square root 7 over 3. Sine is opposite over hypotenuse. Square root 7 over 4. Now if you check this with the Pythagorean theorem, 16 minus 7 is 9. Square root of 9 is 3. This is Pythagorean. This does work in the Pythagorean theorem. It is a right triangle. Cosine of angle A. Ka, adjacent over hypotenuse. 3 over 4. There's example 2. Example 3. Find the height of the building to the nearest foot. So we're going to find the height of this building right here. I'm going to find this side. Call it X. Probably doesn't show up on the screen, but there's an X there. Okay. I have a few problems with this problem. I found the picture, I created this triangle, I put it in on top of there, but I have a problem with the setup. I have a problem with the fact that why is it that we know this is 50 feet in this random problem, but we don't know the height of the building? Why is it that we know this angle way up here? Do we lay down on the roof and measure this angle out to this random piece of string that we know the length of? Why don't we know the angle down here? Anyways, we're looking for X. We know 50. 50 is the hypotenuse. X is adjacent to the 35 degrees. According to SOHCAHTOA, which trig ratio uses the hypotenuse and the adjacent? SOHCAHTOA, which ratio uses hypotenuse and adjacent? Well, there's hypotenuse, this one's adjacent. Cosine. Cosine is the only one that uses adjacent and hypotenuse. Cosine 35 degrees equals adjacent X over the hypotenuse 50. We're going to solve this for X. To solve this for X, we're going to multiply both sides by 50. So we have X equals 50 cosine 35 degrees. Okay, now there's a few things that you have to note here. Notice, I did not put the 50 after the cosine of 35 because you can easily get confused and think that you're multiplying the 35 times the 50. You are not. You're multiplying 50 times the cosine of 35, which is something that you put into your calculator. This is a number. Okay? It's a ratio. It's a fraction. Now, we don't know what that fraction is off the top of our heads. We're going to use a calculator, and we're going to multiply it times 50. Okay? So I'm going to pull out my calculator here. Now, things that you need to know when you look at your calculator. You have to make sure that it says DEG or D somewhere on the screen. Okay? You want to make sure that you are in degrees, not in radians. Radians comes later. You'll learn about radians in this book in chapter 11. For now, just know that radians is another way of measuring angles. We're measuring our angles in degrees, so you need to make sure your calculator is in degrees. Now, different calculators work differently. Some calculators you're going to type this in as is, 50 cosine 35, enter. Some calculators you're going to type 50, 35, hit the cosine button, then hit equals. You need to know how your calculator works. You need to know which order to type it into. How are you going to find out? Well, because you're going to get this answer. 50 times. If you don't get 40.9576, then you've put it into your calculator incorrectly, or you are still in radians, and you need to switch it over to degrees. This problem said round to the nearest foot, so 41 feet is the answer to example 3. Example 4. Find the measure of angle O. How do we find the measure of angle O? Good question. This is new to us. So we know where we are. We're here. We have this 3. We have this 6. This 6 is hypotenuse. The 3, when we're standing here at O, this 3 is adjacent. Which trig ratio uses adjacent and hypotenuse? Again, cosine. Cosine angle O equals adjacent over hypotenuse, 3 over 6, or 1/2. So cosine angle O equals 1/2. Now, I am intentionally going to make a mistake to prove a point, or to illustrate a point. Okay? Our goal is to find what the measure of angle O is, not to find out what the cosine of angle O is. Cosine of angle O is 1/2, but we want to know what the degree measure of angle O is. Okay? So how do we get rid of cosine so that we get angle O alone? Well, we have to find the opposite function of cosine. What undoes cosine, right? For example, if we had x squared equals 25, and we wanted to solve for x, we would have to know what's the opposite of squaring. Well, the opposite of squaring is square rooting. So you would square root both sides. Okay? So the opposite of cosine, or the inverse function of cosine, is not given a fancy name. It's called inverse cosine. The notation is cosine to the -1. Okay, so it looks like we're saying cosine to the -1 power, but we're not. We are saying inverse cosine. Okay, so we're going to do the inverse cosine of both sides. Cosine inverse of the left. Now here's the intentional mistake. Cosine inverse on the right. This is incorrect. This is fine. Cosine and inverse cosine cancel each other. This doesn't make any sense, and let me show you why. I'm going to illustrate why. I'm going to make the exact same mistake over here, and it's going to be painfully obvious to you that this is a mistake here, when this probably doesn't look like a mistake because you're not familiar with what does cosine mean. You're learning. So if I make the same mistake over here, what's the inverse of squaring? Square rooting. square root on the left, square root on the right. You would never make this mistake because this mistake is painfully obvious. It's silly. It doesn't even look right. Yes, those cancel. 25 square root blank. I don't know what that means. Over here, 1/2 inverse cosine blank. I don't know what that means. It's the same mistake as this. So you don't make that mistake. How do we write it? We write it the same way you should write it over here. Inverse cosine of 1/2. So the measure of angle O equals, and you go to your calculator, inverse cosine of 1/2. And again, if you have your calculator set up in degrees and you know how your order is for punching things in, so I'm going to use 0.5. Inverse cosine of 0.5 gives me 60 degrees exactly. Now this, we probably could have guessed early on that it was going to be 60 degrees because this hypotenuse and this is a leg and the leg is half of the hypotenuse. That only happens if one of the angles of the right triangle is 60 degrees. Okay. Example 5. Find the value of G to the nearest foot. So we know this is 23 degrees. We're here at E at 23 degrees. We know the 5 is opposite 23 and the G is adjacent to 23. Which trig ratio uses opposite and adjacent? SOHCAHTOA tells us which one uses opposite and adjacent. The TOA part, tangent. Tangent, 23 degrees equals 5 over G. Okay. Can't tell you how many students make a mistake with this algebra and they multiply both sides by, or divide both sides by 5, and they suddenly have G equals 5 times tan 23. That's not correct. That doesn't make sense. We're going to multiply, cross multiply. So we have G tan 23 degrees equals 5, and then divide both sides by tangent 23 degrees. Tan 23 cancels on the left. G equals 5 over tangent 23 degrees. We go to our calculator. And you hit equals. G is approximately 11.779. And it's asking us to round to the nearest foot. So 12 feet is the answer to example 5. Example 6. Find the values of x and y to the nearest degree. So let's find x first. X is right here. We know the 20, we know the 12. The 20 is opposite, the 12 is adjacent. Which trig ratio is opposite and adjacent? Tangent. Tangent of x equals, let me back up. All right. When do we use inverses? Use inverses whenever you're trying to find the angle measure. It's the only time you're going to use inverse, whether it's inverse tangent, inverse sine, or inverse cosine. You only use inverse when you're trying to find the angle measure. That's what we're going to do here. So tan inverse equals 20 over 12, or 5 over 3. Tan x equals 5 over 3. Inverse tangent of both sides. Cancel, cancel. x equals inverse tangent of 5/3 is 59 degrees, rounded to the nearest degree. Now, we could do this again. You want to do inverse tangent, or tangent of y is equal to 12/20. Inverse tangent of y equals 3/5. So inverse tangent of 3/5. But you're going to get x is 59. Y has to be 31. And you check it on your calculator. 3 divided by 5 is 0.6. Inverse tangent of 0.6, 31 degrees on our calculator. All right, example 7. Find the values of x and y, again to the nearest degree or the nearest tenth. So nearest degree for the y, nearest tenth for the x. Okay, let's find the x first. We're here at the 35 degrees. Actually, let's find the y first. Do we need a trig ratio? Nope. 90 minus 35, 55 degrees. So y is 55 degrees. Let's find x. If I'm here at the 35 degrees, and I'm not going to use the 55. Always use the numbers that are given to you whenever possible. So I'm here at the 35 degrees. I'm looking for x, which is opposite. I know the 20, which is adjacent. Again, tangent uses opposite and adjacent. Tangent 35 degrees equals x over 20. Multiply both sides by 20. X equals 20 tangent 35 degrees. We're going to round this to nearest tenth. Go to our calculators. And I've got 14.0 is the value of x. Okay, and yes, you need the 0.0 because we are rounding to the nearest tenth. What it rounds to. All right, use your calculator to find the following. Parts A and B, we're going to go 4 decimal places. C and D, we're going to round to the nearest degree. So this is some calculator practice. 15 tangent. I've got 0.2679. 74, tangent is 74. 3.4874. Inverse tangent. 1.8040. Inverse tangent, I've got rounded to the nearest degree, 61 degrees. And inverse tangent 1.4826. 56 degrees. Okay. Now, notes, whenever you see the directions that say solve a right triangle, that means find whatever sides are missing, whatever values of the sides are missing, whatever angle measures are missing. So find anything that's missing. Example 9. Find the value of y. How do we find the value of y? I don't have an angle measure. Oh wait, it's still a right triangle. 5, 12, Pythagorean triple, 13. You gotta know those by this point. Sine of x. Sine of x, if I'm here at x, sine of x is opposite over hypotenuse, 5 over 13. Cosine of x, adjacent over hypotenuse, 12 over 13. Tangent of x, opposite over adjacent, 5 over 12. X, I can do inverse sine, inverse cosine, or inverse tangent. I'm going to choose, it doesn't matter which one. They're all going to give me the same answer. Let's do 5 divided by 13 and do inverse sine, and I get 22.6 degrees. 10. Again, to find A, Pythagorean theorem. 149, square root of 149 squared is 149, minus 100 is 49, square root that, A is 7. Okay. 7. Sine of angle B, so we're up here at B. Sine, opposite over adjacent, over hypotenuse, sorry. 10 over the square root of 149. Again, algebra teachers will not let us leave that 149 in that radical in the denominator. 10 square root of 149 over 149. Cosine of angle B, 7 over the square root of 149. 7 over square root of 149, which becomes 7 square root of 149 over 149. Tangent of angle B, 10 over 7. Angle B. Now again, I can do inverse sine, inverse cosine, or inverse tangent. In this case, inverse tangent's a lot easier. I don't have to type in as much, so I'm going to use that one. Inverse tangent gives me 55 degrees. If angle B is 55 degrees, then angle A, 35 degrees. They're complementary. That was example 10. Example 11. Find tangent of angle A and the tangent of angle B. We're going to write as a fraction and as a decimal rounded to 4 decimal places. Okay. So tangent of angle A, so I'm here, tangent, opposite, over, adjacent, tan angle A equals 15 over 36. These both reduce by 3. Tangent angle A equal to 5 over 12. And then round that to the nearest 4 decimal places. Let's go 5 divided by 12. And we're going to go tan angle A approximately equal to 0.4167. That rounds up. B. Tangent angle B equals, now I'm here, 36 over 15, and I'm going to jump right down to the reduced. 12 over 5, 12 divided by 5, it's a nice 2.4. Tangent angle B equals 2.4. Okay, so there's the answer 11. 12. Find the value of x. We're here at the 25 degrees. We know the 12. We're looking for the x. Opposite, adjacent, tangent. Tan 25 degrees equals 12 over x. Let's get the algebra correct. Cross multiply. X tan 25 degrees equals 12. X equals 12 over tan 25 degrees. And we're going to round this to the nearest tenth. Equals 12 divided by tangent of 25. I've got approximately equal to 25.7. That's the value of x. Okay. 13. We're going to use special right triangles to find the value of the tangent of a 30-degree angle. So what is a special right triangle that has a 30-degree angle in it. Make that a little bit bigger so we can see it. $60, 30 degrees. It's a 30, 60, 90, right? If this is, and I'm going to make things a little bit easier for us by going, the opposite of the 30, which is the short leg, is x. That makes the hypotenuse 2x and the long leg x square root 3. Okay? Tangent is opposite over adjacent. Tangent 30 degrees equals opposite x over adjacent x square root 3. Those reduce. 1 over the square root of 3. Rationalize that denominator. Tangent 30 degrees equals square root 3 over 3. Okay? Angles of elevation and depression. Angle of elevation is always measured up from a horizontal. Depression is measured down from an angle, from a horizontal. Always measure from the horizontal, never from a vertical. And you're going to see students making that mistake in a minute. Example 14. All right. Let's go through these. Angle 1, elevation. Angle 2, measured from the boat down to the submarine, depression. Three, from the, actually that's not, yeah, it is a boat. From the boat to the lighthouse, elevation. Angle 4, from the lighthouse down to the boat, depression. Five, from Jim up to the top of the waterfall, up, elevation. 6, from Kelly to the top of the waterfall, elevation. 7, from the top of the waterfall down to Jim, depression. And 8, from the top of the waterfall down to Kelly, again, depression. All right, example 15. Measuring the height of the tree. We stand 40 feet. This is actually a really good problem. It's well designed. There's one small mistake that I will explain to you in a minute on the next page. I think it's the next page. Yes, it's the next page. It's a very well designed problem. I found these three pictures. This is actually a combination of 3 different pictures. It's a picture of the photograph of the tree, it's a cartoon version of a tree, and then it's the triangle information, the math stuff thrown on here, the geometry. So you're measuring the height of a tree. You stand 40 feet from the base of the tree. Okay, so we stand 40 feet. That's something that we can measure fairly easily, that we're standing 40 feet from the tree. Okay, the angle of elevation to the top of the tree is 65 degrees. So if you're wondering, this is a Greek letter theta. It's used in trig, in pre-calculus, and physics. Greek letters are used a lot for naming angle measures. So this is 65 degrees. We want to find the height of the tree, h. We know x, that's adjacent. We're looking for h, that's the height, that's opposite of the 65 degrees. So what trig ratio is opposite and adjacent? Tangent. Start over. I got it from down here. Tangent 65 degrees equals h over 40. multiply both sides by 40. H equals 40, tangent 65 degrees. Hopefully at this point you're good at using your calculators. Use mine. And we're going to round this to the nearest foot. And rounded to the nearest foot, I get it's 85.78, which means that this is an 86-foot tree. Okay. So, like I said, I like this diagram. It's really well done. The one thing that I don't like is right here. What don't I like about it is illustrated in example 16. So here we have a choice of two diagrams, and all I want you to do is tell me which diagram is more realistic, more like a real-life problem. Now, I have had students say that it's not this one because this person would never be this big compared to the Eiffel Tower. Well, and I would say maybe that's just perspective. They're just really, really far away. This one is the least realistic, and I'll tell you why. We don't measure things with our toes. We measure things with our eyes. We measure things from our eyes because that's what we can see from. We don't see out of our toes. We can't measure things from our toes. Although this is a typical book problem, and we're probably going to see this again in a future problem down the line, but we don't measure things from our feet. We'd have to be laying down on the ground to measure this angle of elevation, these two different angles of elevation going up. Now, yes, we might do this problem like this to solve the height of the flagpole, okay? But we would never measure it from our toes. We'd be measuring it from our eyes. So which diagram is more realistic? Diagram A. Example 17. Find sine, cosine, find sine of angle A, sine of angle B, cosine of angle A, cosine of angle B. We're going to write each answer as a fraction and as a decimal. Sine of angle A. So if we're here, sine opposite over hypotenuse, 15 over 39. 15 and 39 both reduced by 3. 5 over 13. Sine of angle A is equal to, let's see, 5 divided by 13. As a decimal, let's go 4 decimal places. 0.3846. 0.3846 sine of angle A. Sine angle B. Angle B is here. We got 36 over 39. Again, these both reduce by 3. 12 over 13, sine of angle B. 12 divided by 13. 0.923, and it rounds up to a 1. And again, let's go back. These ones are approximates. I'm rounding those decimals. All right, cosine. Cosine angle A. Cosine of angle A is the same as sine of angle B. Complementary functions make things easier for ourselves. 12/13, or approximately 0.9231. Cosine angle B is equal to the sine of angle A. Again, save of time and energy, 5/12, or approximately 0.3846. Okay. Example 18. Write cosine of 69 degrees in terms of sine. Well, if cosine of 69 degrees, what's the sine equal to? Cosine 69 degrees equals the sine of its complement. What's the complement of 69 degrees? 21 degrees. Sine of 21 is the answer to example 18. Example 19. Find the values of x and y using sines and cosines. So let's find the value of x first. We know this is 35. X is opposite. 53 is hypotenuse. That is sine of 35 degrees equals x over 53. Multiply both sides by 53. X equals 53 sine 35 degrees. And rounding to the nearest tenth. Go to our calculator. 53 sine of 35. And I've got 30.4 is the value of x. Now I could, if I wanted to, use Pythagorean theorem to find the value of y, but the directions say use sine and cosine, so we're going to use cosine this time because y is adjacent to the 35. I'm still going to use the 53, which is the hypotenuse. Cosine 35 degrees equals y over 53. Again, multiply both sides by 53. And we get y equals 53 cosine 35 degrees. Y is approximately, we'll go to our calculators, approximately 43.4, which should be the same thing that we would get if we used Pythagorean theorem. All right, that was example 19. Example 20. Which ratios are equal to square root 2 over 2? Select all that apply. So here this is 45, 45, 90. This is 9. What's this? This is 9 divided by the square root of 2, or 9 square root 2 over 2. This is also 9 square root 2 over 2. Sine of 45 degrees, sine of A, it's going to be 9 square root 2 over 2 over 9. Over 9. What's that reduced down to? Square root 2 over 2. There's one of them. Okay. Cosine of angle A. 9 square root 2 over 2 over 9. Again. Sine of angle B. Well, this is 45 degrees. This is 45 degrees. 9 square root 2 over 2 over 9. Again. Cosine of angle B. One more time. Tangent of angle A. All right. Tan angle A. Opposite over adjacent. 9 square root 2 over 2 over 9 square root 2 over 2 equals 1. Tangent of angle B also equals 1. Which trig ratios equals, and you're going to find when you take trig and pre-calculus, these are special right triangles are going to come back again, and the trig ratios for those special right triangles are things that you're going to have to memorize. For now, you can calculate, we can figure them out. But when you take trig and pre-calculus, you're going to memorize these ones. Which ratios are equal to square root 3 over 2? Select all that apply. Sine of m, this p here. when I took this picture from the book. The P wasn't in the book. So sine of angle M, sine is opposite over hypotenuse. Sine of angle M is equal to the cosine of its complement. Sine of angle P, opposite over adjacent, 1/2. Cosine of angle M is equal to the sine of its complement. That's going to be 1/2. Tangent of angle M, square root 3 over 1, square root 3. Tangent of angle P is the reciprocal of that, square root 3 over 3. So the only two that equal square root 3 over 2 are M and P. And again, these are ratios you're going to memorize when you take trig and pre-calculus. Okay, you are skiing down a hill at an altitude of 800 feet. So this, I'm changing this to 800. Instead of redoing the entire diagram, I just took this diagram from the book and I'm changing the numbers. The angle of depression is 15 degrees. Again, different from the book. But notice this is where we put the 15 degrees. It's always measured from a horizontal down if it's an angle of depression. Okay? We want to find the distance that you ski down the hill, x. So this is specific that we're skiing down the hill and we're finding the distance that we go down the hill. Sometimes I'm going to say find the diagonal distance, that would be this x. Sometimes I might say find the horizontal distance, that would be this one here. This one's asking, or this one up here, because they're the same, they're making a rectangle here. We're finding this diagonal distance. We know the 800, we're looking for the x, we are here at the 15 degrees. 800 is opposite, x is hypotenuse, sine 15 degrees equals 800 over x. There's our equation. Cross multiply, x sine 15 degrees equals 800. X equals 800 over the sine of 15 degrees. X is approximately equal to, our calculator here, calculator, 800 divided by sine of 15 degrees. X is approximately, rounding to the nearest foot, 3,091 feet. Is the answer to example 22. All right, example 23. Determine which of the two acute angles has a sine value of 0.4. Okay, so is sine of R 0.4 or the sine of Q 0.4? Sine of Q, angle Q equals 3 square root 21 over 15, or 3 or square root of 21 over 5. 21 square rooted divided by 5. That's equal to approximately 0.9. It's not that one. Sine of R better work. Sine of R is 6 over 15, which reduces down to 2/5, which is 0.4. So sine of angle R is equal to 0.4. All right, example 21. Let's get some more calculator practice again. Let A, B, and C be acute angles. Use a calculator to approximate the measures of A, B, and C to the nearest tenth of a degree. So we're looking for the angle measures. We use inverse tangent, inverse sine, inverse cosine. So inverse tangent of 3.29 is measure of angle A approximately equal to 73.1 degrees. Measure of angle B. This time we're doing inverse sine. 0.55. This time angle B is 33.4 degrees. And the measure of angle C, inverse cosine this time, 0.87, inverse cosine, 29.5 degrees. Some good calculator practice there. Solve the triangle. So we saw earlier in this unit what that means when we say solve the triangle. Solve the triangle means find all the missing information. Solve round answers to the nearest decimal answers to the nearest tenth. So if there's a decimal, we're going to round it to the nearest tenth. To find the length of segment AB, Pythagorean theorem. And it's a Pythagorean triple. 7, 24, 25. AB equals 7. Okay. We got to find the B and the measure of angle C. To do that, we can use inverse sine, inverse cosine, inverse tangent. It doesn't matter which one. Let's go with angle A. So to find the measure of angle A here, I'm going to use the 24 and the 25, not the 7. That's opposite and hypotenuse. So that's sine of angle A equals 24 over 25. And let's see. Inverse sine angle A. So inverse sine of 24 over 25 becomes divided by 25. Inverse sine of that, 73.7 degrees. 73.7 degrees. We're not going to use trig again to find C. We're going to subtract from 90. And I get angle C, measure of angle A. Measure of angle C equals 16.3 degrees. 16.3 degrees is the measure of angle C. Example 26. Solve the right triangle. Again, we're going to find the missing information. Find the y first, the value of angle y. If this is 41 degrees, subtract that from 90. 49 degrees. So the measure of angle y equals 49 degrees. To find x, I'm going to do sine. I'm here at angle x. So to find the little x, and notice little x is opposite the big X, little y is opposite the big Y. This would be little z, and that's traditional trig notation. So we've got sine of 41 degrees equals x over 18.4. Multiply by 18.4. X equals 18.4 times sine of 41, and I get x is equal, rounded to the nearest tenth, 12.1. To find the value of y, I'm going to use cosine. Cosine 41 degrees equals y over 18.4. Again, multiply both sides by 18.4. and y, I'm going to change these to approximately, sorry, y is approximately equal to 18.4 times cosine of 41, and I've got 13.9. And if you do 12.1, 13.9, and 18.4, they should work in the Pythagorean theorem. All right. Example 27. Your school is building a raked stage. That's a stage that has an angle to a pitch to it. The stage will be 25 feet long from the front to the back, diagonal distance, with a total rise of 1.5 feet. You want the rake to be 5 degrees or less. Is the rake from the stage within your desired range? Let's take a look at the diagram. Right angle. We've gone up 1.5 feet. And this is 25 feet long. We want to find the value of this angle. Call it angle x. Okay. Which trig ratio do we use to find the value of x? Opposite hypotenuse. Sine of angle x equals 1.5 over 25. Inverse sine is going to get us the value of x. Measure of angle x equals inverse sine 0.5 divided by 25. Inverse sine of that. And I've got 3.4 degrees. That is less than the 5 degrees. We are within the desired range. Stay tuned for part 2 of this section.